In this domain, we cover secure software requirements. This is a particular domain of the Certified Secure Software Lifecycle Professional, and software requirements is a key part of the software development lifecycle. And so understanding your actual requirements is key to actually building and developing your product with security built in. So policy decomposition. So policy decomposition involves the mapping of high-level policy requirements into low-level policies, a process that can be repeated until the policies are implementable. For example, there could be a requirement that says the system, based upon its classification, shall implement this particular set of requirements. That's the high-level requirement. It's very high-level, very abstract. But drilling down further until you get to your CSCI or CI or your particular subsystem, then the requirement becomes more specific. You know, you can talk about, well, within those requirements, I need to implement cryptography. And now it may just say you must have data in transit, you know, must encrypt data in transit. And from there, then will come the type of encryption you need, the methods that you actually implement that data in transit. Does it need to be a type 1, type 2, or type 3 product? Meaning, does it need to be have an approved algorithm or stuff like that? Does it need to have transmission encryption key, key encryption key? Does it need to have an approved key management plan? All these particular items that happen due to a high-level requirement as you further decompose those requirements into low-level requirements. And that's what policy decomposition is. So per Federal Information Processing Standard, or FIPS 199, and USC section 3542, the terms confidentiality, integrity, and availability are defined as follows. Confidentiality: preserving authorized restrictions on information access and disclosure, including means for protecting information, personal privacy, proprietary information. Integrity: guarding against improper modification or destruction, and includes ensuring information, non-repudiation, and authenticity. Availability: ensuring timely and reliable access to and use of information. Now, this is the CIA triad, which we cover over and over in this course. It's also, in some books, is the AIC triad, which is, of course, availability, integrity, confidentiality. But understand how AIC plays in part of these different domains is key. So for availability, you could have a requirement that says the system needs to have, 4 nights or 5 nights of availability. So then, which part of the system does that requirement go to? Does it go to the entire system, or the entire application, or does it go to various components within the application? And so that's important in further decomposing your requirement. Now, integrity, you can have requirements for integrity as in the ability to check for modification of messages or data and stuff like that. And so in terms of making sure that that particular requirement or that requirement that says this data needs to be proved is not modified, you would have maybe a particular check that looks at looking at hashes and things of that nature to look at integrity. Say I want to do a SHA-1 or whatever, or MD5, do hash this particular item, and so you're checking particular hashes to see if this actually has been modified and stuff like that. And then confidentiality, any of those models that we talked about earlier that relates to the subject accessing the object or interacting with the object, that could deal with confidentiality, access controls and things of that particular nature. And for a check like this, you could simply have an individual of a medium classification log on to a system and see if you can access information that is deemed high. And so that would be a way of checking a requirement for confidentiality. So confidentiality: who is authorized to see what specific elements? What mechanisms should be employed to enforce confidentiality? And then what are the business requirements with respect to data collection, transfer, storage, and use with respect to confidentiality? Integrity: who is authorized to author which specific data elements? What mechanism should be employed to detect errors to enforce integrity? What are the business requirements with respect to data collection, transfer, storage, and the use with respect to integrity? Availability. So this is concerned with two issues: ensuring systems are available for authorized users when they require those systems, and denying access to unauthorized users at all times. Identification and authentication. So the identification step requires the following issues be determined by requirements: mechanism to be used for identity, management of identities, including reaffirmations, and other issues for authentication that need to be resolved included method of authentication management, strength of authentication management. For systems where more demanding security is needed, a more complicated system such as cable system may be employed with encrypted secrets. The concept of tokenization also can be extended to other shared secrets such as biometrics. Authorization. Once a user is positively identified by the system, an authorization determination still needs to be made. So you have MAC, this is mandatory access control. DAC is discretionary access control. So MAC, basically, a subject's access to an object is predetermined by the property that is defined by the rules associated with the system. And then with discretionary, here it's saying that both discretionary and mandatory access control are terms originally used by the military to describe two different approaches to controlling what access individuals has to one system. One common method to accomplish this is via the permission bits used in Unix-based systems. The owner of a file can specify what permissions, read, write, execute. This is your 421. This is when you use the command in the terminal, the chmod, and then here you can do like 777, which is read, write, execute to all. And so basically it's just the owner that can specify the permissions, and then it could be members in the same group and members and others, and what particular rights they can have. So role-based access control. Access control lists can be cumbersome and take time to administer properly. Another access control mechanism that has been attracting increased attention is the role-based access control. And so the role-based access control are access controls based upon the roles. So I can say, you as a system administrator have access to all the particular folders and applications that a system administrator needs to do their duty. Now, I'm going to talk about rule-based and jump back to role-based. So rule-based access control, the first thing that you might notice is the ambiguity that is introduced with this access control method, also using the acronym RBAC. Rule-based access control again uses objects such as access control lists to help determine whether or not access controls should be granted. However, a set of rules is contained within the ACL. So I can have two engineers, right? I have two system engineers. So these system engineers are working on various projects. And so since they are system engineers, they have access to these particular applications, maybe DOORS, which is Dynamic Object-Oriented Requirement System. They have access to DOORS, Enterprise Architect, and a few other items to do their job as a system engineer. However, if they need particular access to folders and other things like that, I would have a rule-based access control that kind of looks at, what charge code these engineers are charging to. So they're charging to program A that requires access to these particular files and these particular systems, then they would have access to that. But once they were off that charge code, they would no longer need access to those files and folders for program A. And so that's when you use RBAC with the rule-based and the role-based together. All right, so for auditing, the information system security policy decomposition for auditing services should consider both the risk-based and organizational characteristics. The risk-based issues can be examined as cases of the three forms of audit-related risk. These risks are also known as residual risk. You have inherent risk, detection risk, and control risk. Now with auditing, if you look at the Department of Defense, we'll just say we're going to audit data that's classified, right? And so if you look at the auditing requirements, the former DCID 6.3, and you look at the former DICAP, they had specific auditing requirements for information or data based upon its classification. So in the commercial realm, you have to understand what are the actual requirements for auditing data, right? So how long do you actually need to retain it? If it's, is it 3 years, is it 5 years, is it 1 year, is it 6 months? Understanding this requirement so you can further say, all right, I'm going to generate this data. However, I need to have another system because I need to move that data to the system, and it has to have these particular protections on the system. So inherent risk are those risks associated with the process and its inherent error rate, assuming no internal controls exist to handle the potential errors. When decomposing policies, the following organizational security elements should be explored for auditing: roles and responsibilities, separation of duties, training and qualifications, change management, control management. So for auditing, the training and qualifications, this can be done by HR. So you can say, oh, HR, I need to check to make sure this particular individual has a computer science degree or software engineering degree or information systems degree working on this particular project as deemed by the actual granting agency for that particular contract, if it is federal or state organization. And then also, if it is a DoD-based organization, I could say this particular individual should have the DoD 8570 qualification or certification based upon the particular role they're playing on the program. Whether it is a management, technical, or engineering role, they need to have this particular certification for the level role they're sitting in. Now, for those that understand that particular requirement, it will change with DoD 8140. However, that is something that gets audited. Now, for the commercial side, there's not really a hardened rule about a particular training or qualification. Mainly it's just degree. Certification was nice, and usually the CSSP or other certifications such as CISM or CISA is used as a disqualifier amongst people that apply. And that's usually the qualification, and then training is usually a technical degree. But for organizations that do work within the government or support the government, they have to follow the DoD 8570, which is very stringent on what is required for a particular position. Now, separation of duties. Now, this is an interesting thing. So this is just making sure that separation of duties and roles and responsibilities, they can be kind of tied together. So making sure one individual doesn't have 3-4 roles and that those particular roles are not going to allow for separation of duties. So you can't have the programmer and the individual that is providing all the development of the tools and stuff like that, or the manager, the actual HR guy, and then the engineering manager. They can't be one. So this is all important stuff. So here it just says that some typical internal requirements could include protecting audit logs. So again, storing them, encrypting them, password protecting them, just ways to protect them, managing data loss prevention elements, monitoring internal system traffic. You can have an IDS, intrusion detection system, or a intrusion prevention system, but something to actually monitor internal system traffic. You can just even have Wireshark running, just looking at the traffic. Of course, you have to analyze it as well. So I would recommend a tool like RapidMiner or something R-based that you can actually put in a, you can do some type of statistical programming or analytics against it, but something that you can port over, which will allow like a CSV, because from CSV it easily imports to most analytic tools. And then monitoring internal controls. Now, external requirements, it can be looking at managing external connections with security controls, managing external connections and authentication, and then employing content filtering and proxies to protect against web-based threats. Again, IDS, IPS, things of that particular nature. Now, one of the key elements in security is identifying which assets are critical from a security point of view. And then data can be classified in several different manners, each with a level of significance for security. And data classification in itself is a risk management tool with the objective to reduce the costs associated with protecting data. Now, for those that are familiar with the Department of Defense, top secret, secret, and class, commercial, high, medium, low, or you may have a proprietary classification on your actual data. But with these particular markings, now you know that, hey, this is the data that's coming through this particular system. The system should be treated as such. The system should not be touching other systems or individuals working on a system that don't have this particular access to data. And so knowing that the data classification, you're given kind of a guideline on how you should interact with the data, which is very important. Here you have data, talking about data sets. So data can be considered a static item that exists in a particular state at any given time. For the purposes of development security, these states are at rest or being stored, being created, being transmitted from one location to another, being changed or deleted. And then in addition, one should consider where the data is currently residing, or permanent media, remote media, and RAM on a machine. So you may have requirement for, let's say, encrypting data at rest. So if you're going to be encrypting a data at rest, that could also mean remote media. And so there's a few particular USB drives that meets FIPS 140-2, I think level 3, if I'm saying it right. But it's basically the DoD, or it's a federal government requirement for actually encrypting data. So you may have to meet something like that. And so, this may also, provide the guidelines, or it may determine how you deal with media on an external drive. Does it have to be wiped after so many false attempts of getting it? Does it have to be an approved software that's on the device to actually do the encryption? All these different things. And then in the RAM on a machine, now you have to figure out, okay, well, how do I worry about volatile and non-volatile memory and stuff like that? So here, just talking about the classifications. So internal data, so data initialized in the application, used in an internal representation, or used in a computation and stored. Input data, so basically data that's read into systems and possibly stored in an internal representation or used in a computation and stored. And then output data, so data written to an output destination following processing. In addition, data can be considered security sensitive, marked as contain personally identifiable information, or to be hidden. These categories can include security sensitive data, so basically a subset of data of high value to an attacker. PII data, so data that contains PII elements. And then hidden data, so data that should be considered to protect it from unauthorized disclosure using obfuscation techniques. Data can be classified as to the specific risk associated with the loss of the data. Data ownership, so understanding really who owns the data. So data doesn't really belong to people in an enterprise. It's actually the property of the enterprise or the company itself. The data owner, so the data owners act in the interest of the enterprising, managing certain aspects of the data. The data owner is the party who determines who has specific levels of access associated with the specific data elements, who can read, who can write, who can change, delete, and etc. The data custodian. The data custodians support the business use of the data in the enterprise. Data custodians may not require access to the read data element. They do need appropriate access and policies to the data elements. Labeling, so labeling the data so that, label that external drive, label that machine, so that only individuals know clearly that this machine is marked low and I should not put anything that's marked medium or high on this machine for actually processing. So because data can exist in the enterprise for an extended period of time, it is important to label the data in a manner that can ensure that it's properly handled. And then sensitivity, so data can have different sensitivity levels within an organization. So impact, the impact that data can have when improperly handled is much wider concern than sensitivity. So typically there are three levels: high, medium, low. And then the first step in impact analysis is defining the levels of high, medium, low. The types of data. So data can come in many forms, and it can be separated in two main types: structured and unstructured data. So structured data has defined structures and is managed via those structures. Unstructured data, the data is the rest of the data in the system. So data lifecycle, data in the enterprise has a lifecycle. It can be created, used, stored, and even destroyed. And then data can be generated in the enterprise in many ways. It can be generated in a system as a result of operations, or it can be generated as a function of some input. Retention, data that is going to be persistent in the system or stored must have a series of elements defined. Who is the data owner? What is the purpose of storing the data? What levels of protection will be needed? Now, with what levels of protection will be needed will be, of course, based upon the data classification, and then the requirements that are tied to that data classification, and then how long it will need to be stored. Again, that is going to tie back to the requirement. So if it's a requirement for like high data, it's a high level data, then there will be particular requirements that say, hey, maybe this data needs to be held or stored for 3 years. And then that data needs to be retained for 3 years. And then after 3 years, it can be destroyed or it can be turned over to the organization that are responsible for that particular type of data. Now, disposal. Now, data destruction serves two primary purposes in the enterprise. First, it serves to conserve resources by ceasing to spend resources on data retention for elements that have no further business purpose. And then second, it can serve to limit database liability in a specific legal situation. Now, there are programs like Darren's Boot and Nuke that actually has a DoD write pass for data. And so with disposal, it also has to be an approved system that actually wipes the data from the media. So that's something that's not mentioned here, but that is essential. You need to actually use a tool that's approved for actually wiping and removing the actual data associated with the system. So requirements, they're the blueprint by which software is designed, built, and tested. You have functional requirements, and these requirements describe how the software is expected to function. Role and user definitions, so these are statements of who will be using what functionality of the software. And then objects, so items that are the users, this is subjects, this is us, will interact with the operation of a system. Now, in the earlier presentation, we talked about the subject not interacting directly with the object. There's something in between that provides kind of a access methodology or methodology for actually accessing the particular object. As we talked about Bibba, Bellapodule, and stuff like that, these are different models, and Clark Wilson and stuff like that, different models for how the actual subject and object interact. So activities and actions. So the permitted activities that a subject can perform on an associated object, and then a subject object activity matrix. These are basically, it's just a matrix that says the subjects represent who, objects represent what, and the activities or actions represent how the subject object activity relationship. It's just a big matrix that says, you have subject down on the right hand side, and then on the top it has the object, and then inside it says it has the X, like can you read, write, execute, and then all the particular objects that the subject can actually interact with. Use cases, powerful technique for determining functional requirements in developer-friendly terms. And then use case modeling shows the intended system behavior for actors. Abuse cases, these are misuses or abuse cases can specifically considered a form of use illustrating specifically prohibited actions. Sequencing and timing. In today's multi-threaded concurrent operating model, it is possible for different systems to attempt to interact with the same object at the same time. So here you have race conditions, which are software flaws that arise from different threads or processes with a dependence on an object or resource that affects another thread or process. So secure coding standards are the language specific rules and recommended practices that provide for secure programming. Application programming can be considered a form of manufacturing. So with secure coding, this is something that's not really, that hasn't been taught. When I did undergrad and master's and whatever, secure coding wasn't really taught until I was really in my doctorate. Undergraduate, coding was like, oh, this is how you code. These are the languages. These are the various rules that you should understand with the language, very nuanced and stuff like that, and limitations. And this is used for mobile. This is used for web. This is used for, this allows you to do more powerful things and things of that particular nature. But now with secure coding, now you say, hey, I understand, I'm learning about various flaws associated with languages. I'm learning about static and dynamic code analysis. I'm learning about looking at and evaluating source code. I'm looking at checking for the common weaknesses and enumerations for that particular item. And so these are all items that are part of secure coding. All right, so operational requirements. So software is deployed in an enterprise environment where it is rarely completely on its own. Enterprises will have standards as to deployment platforms, whether it's Linux, Microsoft, Windows, and then specific types and versions of database servers and other infrastructure components. And then the deployment environment, software will be deployed in the environment as best suits its maintainability, data access, and access to needed services. Now, the RTM, or the requirements traceability matrix, is a grid that assists the development team in tracking and managing requirements and implementation details. So the RTM will have requirements in there from security. So you security people, so for software, you'll actually figure out what the actual software requirements are. You'll decompose it from the high level to the low level. And then those requirements will go into the RTM. And then from there, the developers will see the actual security requirements that are needed for their particular application.